Welcome, this is Black Lotus, your YouTube script kiddie, and today I'm just going to go over the code that I use to model an auto MPG dataset for predicting the miles per gallon a car might have. The data was collected from the UCI repository. It is in fact called auto MPG dataset. So the code that I use for modeling involved these libraries that are presented here. I tried several regression techniques, as well as used cross-validation and standard scalar as my scaling technique. I did use four cores that I specify for n jobs during the cross-validation, and in the main portion of the code, I specify the path to my model. The data set was actually separated by tabs, not commas. And the column names I had to provide manually. I also provided the data types manually. So I formatted the data so that I could get it into a cohesive CSV. There were missing values for horsepower, so my idea for filling in those missing values for horsepower was to find all the cars for the missing values of a given car, the cylinders and the make of those cars, and to find the average of the horsepower and fill that in as the missing value. So to do that, I created four separate data frames for the make and cylinders combination, found the mean value of those horsepower, and then put that into the main data frame. Afterwards, I was able to specify the data types for all the columns. During the actual modeling process, I set three static variables: max iterations, cross-validation number, and my random state. My random state is pretty self-explanatory, just picked a number. Cross-validation I like to set at 10. I find that usually works the best for me. And any model that required a max iteration I set at 10,000 iterations. To determine which columns I wanted to use, I used a pair plot from Seaborn. Just bring that up right now, and we can see from the miles per gallon, it seems like these columns are displacement, horsepower, weight, and model year seem to have a pretty good relationship. So this would be displacement, this one would be horsepower, this one would be weight, and then this one would be model year. So cylinders and acceleration would be left out. And you can see I set my X variable to those four columns. Then I set my Y variable to MPG, miles per gallon, which was the very first column. The scoring metrics that I wanted to get were R2, adjusted R2, root mean squared error, and median absolute error. SKLearn provides the scoring for R2, root mean squared error, and median absolute error, but not adjusted R2. So I created my own R2 function, adjusted R2 score function. Set up a standard scalar for models that need to have scale data, and then I set three dictionaries. So one is a blank dictionary for CSV scores, one is a dictionary for the algorithms which do not need scaled data, and then a dictionary for models which need scaled data. I then ran cross-validation. I looped through both the regular and the scaled algorithms, did cross-validation on all the models, and stored them into CSV scores, and then just found the mean average, the mean scores for each of the score metrics. And just to show that this actually does run, I'll go ahead and open up a REPL, and I'll go ahead and run the script. It does take a second. A couple of the models do take a little bit of time, mostly the multi-layer perceptron and the k-nearest neighbors regressor. The dummy, the linear regression, as well as the lasso and ridge take practically no time at all. And as we can see, we have our cross-validated results. The two that seemed to perform the best were the random forest regressor and the multi-layer perceptron. The random forest model has an adjusted R2 score of 0.71, and root mean squared error and median squared errors are not that great, but none of them really were. And the multi-layer perceptron, the adjusted R2 score was for cross-validated scores was 0.73. And again, the root mean squared error and median's absolute error weren't too great either, but it is a pretty basic model. I saved them as a joblib and the scale for the model and the scalar. So as you can see over here, I have a joblib model and a joblib scalar, and those are what I used in the GUI app. So I'll switch over to the GUI app. I built this in a similar way to the classifier, except I used regressing metrics instead. I added a getScalar in the classifier. I didn't need to scale the data because the model that was chosen was a random forest. Here, the best model out of my basic modeling and scripting was a multi-layer perceptron, so I added my scalar as well. I just created 4 widgets, one for displacement, horsepower, weight, and model year. The 4 columns that I saw from my pair plot that had a decent correlation, or from a brief glance had a decent correlation with miles per gallon. And just set up the widgets and a predict button to display the prediction. And just to show that that runs, I'll go ahead back into my REPL. I'll go ahead and run autoapp.py. And here it is, my GUI application. And then we can put in whatever values we want. I just put in some random values. 1970 will be the date, and my displacement, I don't know, 1, 2, 3, 4. Predict MTG. And the miles per gallon prediction will be 18.351 miles per gallon for these 4 metrics. And that's it for showing the code for this regression model. Pretty basic modeling. If you wanted to improve it, you could do some grid search to find the optimal parameters for the multi-layer perceptron or any of the other models that I tried out. But that's all I have to show. Thanks for watching, and I hope you got something out of it.